Hi, I'm Dave Robinson, and welcome to another screencast where I'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, an amazing weekly data project in R run by the R for Data Science online learning community. And if you're joining me live, I definitely invite you to ask questions, give ideas in the chat. I can see the chat window in another screen, so definitely feel free to interact. It's one of my favorite parts of doing these screencasts live. So let's see what data set we have today. All I know about it is this elevators, and I did see that it was on Twitter that it was elevators in New York City. So it looks like it's a data set of the registered elevator device in New York City provided by the Department of Buildings, response to a FOIL, Freedom of Information something request. So, all right. From Emil. Oh, that's cool. And I think it's gonna be really fun. I live in New York City, so I'm definitely excited to see what data we have and what we can learn about New York City elevators. So generally, I use Tidy Tuesday, use Tidy template. Here we go. I usually load up scales, theme set. Oops. Light. Sometimes I use Lubridate. I'm going to bring that in so I don't have to remember to later. And often I just keep this part where I bring in the Tidy Tuesday data from today. Let's see. Elevators. Okay. Oh, it's not popping up the preview. That's okay. We've got elevators. All right. So what kind of cleaning would I want to do on this? I might want to do clean names to turn them into snake case. And let's see. Oh, wow, that is a lot of information. Not preview, view. That is a lot of information. We have 76,000 elevators, and we have device status, description, so work in progress, active, bin. Let's take a look what columns we have. We have building identification number, tax block, these are locations, zip code. That's cool because zip codes we can do a lot of interesting things with, including mapping. And device types like passenger elevator, or presumably like industrial elevator, etc. Last periodic inspection and as of 2015. All right, wow. Speed, capacity. Do we have a number of floors here? Let's see. Because I'm really curious, like, where are the highest floor, not cleaned. Ooh, we're gonna get to clean the data ourselves. And we have latitude and longitude, so we can do maps. There's so much that I can do with this. Thank you, Emil. This is a really cool. Data set. So let's start by let's see. Let's save it as elevators. Still getting warmed up today. Let's go with device status description. All right, sort equals true. Mostly it's active, and then some that are a work in progress or whatever. And let's see, what is going to be our favorite one? I'm just going to make a plot of the elevators and longitude, latitude, geom point. I'm just going to make a plot of the and see if does it look like New York City. We have one for every building, presumably. All right, there's one outlier, so I'm actually going to filter out the outlier. What are the boroughs? I'm guessing that outlier. Let's see if I did. There are 5 boroughs in New York City. I live in Manhattan, and what is this weird outlier? Is that a miss? That is not in Brooklyn. That is the bad data point. And yeah, I'm going to go ahead and I'm going to filter it out. I'm going to say filter longitude greater than 70, than negative 76. Maybe it's a good data point. Doesn't matter. I'm going to go ahead and clean it on out. Here we go. Here's our elevators. And yeah, what I'm actually going to do now, let me see, is I really like this idea of floor. So I'm going to, let's see, I'm going to look at that, what was it called? What was that? What was the name of the column? It was called so many DVs. That's Department of Vehicle. I don't like that. So I'm going to do rename all, string remove, start DV. That way it's going to remove DV from the start of any of these, yeah, it's not like device, so and it already says device. So here we go. And now I could just say elevators. And it was called, let's see, floor from floor 2. So let's make a plot of, let's actually, no, I can't do a plot because it's going to be, it's not clean. Varying formats, and let's see, filter not is an A, floor 2. I'm mostly interested in the floor 2. Okay, some of them are going to be basement. Let's do a count of just floor 2. I think floor 2 I'm especially interested in because it's, here we go. So it's a string and mostly numbers, but definitely also some penthouse. Well, penthouse won't tell it, and basement we basically know where it is, but I don't know what R and ST would stand for. I'd imagine there's some things like mezzanine or stuff like that. Let's go ahead. Let's see. I'm just looking through for a second. Are there things? Some are dates. So that's just junk data. That's junk data. Yeah, and some of them I don't trust at all. And the letters, yeah, I have no idea. So outside of basement, well, I don't. Oh, I guess maybe none are. Very few are from the to the basement. So I'll go ahead and do okay, floor 2. Hey Emil, I'm having a lot. Thanks for joining. I'm having already some fun with your data set. This is a really cool data set. Now we could. The interesting about this, it's gonna warn me that there's so many there's gonna be so many NAs. That's okay for me because I want to just keep the I want to just keep the ones that are numeric, and the ones that are strings I'm not going to deal with today. Here we go, and labels equals comma format. Here we go. What's 1,000? What's to floor 1,000? That's some junk. Let's see. I'm gonna do. Let me see. I'm gonna say floor 2. Gonna call it floor 2 clean. No, I don't like calling it floor 2 clean. I'm gonna call the other one floor 2 raw. Floor 2. I like that. And yeah, so what are these supposedly arranged descending floor 2? Select house, street name, zip code, borough, and floor 2. House number, I suppose. East 105 East 18th Street. Well, that's annoying that it I thought it was in 5 digits, but it has a lot of it has 4 zeros on the end of it. That's okay. We'll fix that actually. Let's go ahead and fix that. So say zip code is, I'm going to assume as character zip code. I'm going to assume that if I do string sub of this from 1 to 5, that it's going to get me some good zip code. You know, it's not quite, is it? Because if they start with 0, but I don't think any in New York do start with 0. So I actually think we're probably okay here. Count zip codes. Some are 0, and I'm gonna go ahead and do an NA. I'm gonna do this on the inside one. I'm gonna say NA if it's 0, that probably just means missing data. Yeah. All right, these are real New York zip codes. At least I recognize a couple of them. So we here we go. I just like this a bit more. There's no way there's 912 floors. Just nope. That's not a thing. There's some typos and such. The Empire State Building is something I think about 100 floors. Or maybe yeah. Although I don't know exactly what the heights the elevators go to. And I'm gonna go ahead and just say filter for floor 2. I'm going to say floor. I like how many examples there are where I can make my choices. Floor 2 is greater than 100, NA, I can't use NAF there. Floor 2. All right. And now some of these are still false. I don't know what this building in Queens is, but it's not gonna be 94. This is the Empire State Building. These other ones, I'm not so sure. What is at 845 First Avenue? If that's the I don't know, like if that's One World Trade or if that's Trump World Tower. That number of, I tried Googling a different one, number of floors. 90. Okay. So the so this one is plausible. I don't think this one is. I don't think there's one on 43rd Avenue in Queens. It's 94 floors tall. So I'm gonna go ahead and set if it's greater than 90. Now notice there are multiple elevators in the same building, so we're gonna have to observe that. So the good question from Matthew, which is when I want the number, I want to use parse number. Surprised as.numeric worked. There's actually a reason I chose that intentionally because as numeric will give an NA if there's any characters. If I say outside of a dot, so if I say as numeric 5A, it'll just do NA. Whereas if I do parse number 5A, it'll say you probably meant the 5. I'm trying to be extra safe because I don't necessarily know what does A5 mean? Like, does it mean the 5th floor? Or does it mean, I don't know, like the 5th version of floor A, which is the 2nd floor? I have no idea, but I feel pretty good about these numbers. And I'm saying that I'm going to max out at 90, which is Trump World Tower. So what I'm noticing also is some of these are the same building. So I might want to say, let me see, building ID. I can do group by building ID as well as house number, street, zip code, and borough. And let's include device type. It's not, let's not do this because I'm aggregating now. Summarize, max floor is max floor 2. This is the top, this is not the height of the building. This is the height of their highest elevator that is correctly tracked. So it's not going to be perfect, but it's pretty. This is going to be a lot better than I really don't know like other data sets that can more or less every building in New York that has an elevator, which any building is rather a certain height will. This is really quite cool. So now we can say here are the tallest buildings, and we have Trump. We have hold up. Let me see. One of them. So West 57th. Is this the other? Let me see. Is this? I don't know which one this is. Which is 157. I'm what am I doing? Doing in another window? I'll be more social than that. I'll say 157. This, and whoa! That's that super tall one that you can see south of it. It's a tall, thin building. Do I have a picture of it? Let's see. Or is it the thin one, or is it the... No, it's the... No, yeah, it's a tall building. So it's not crazy that's tall. All right, and then there's some others, 10 Columbus Circle. Okay, yeah, not all the buildings I'll definitely I won't recognize all of them. But now we have by building. And we have it by building ID, and let's see, what else would I want to... I'll say N... summarize max floor, and I'll say N elevators is N, and I'll also say dot groups equals drop. I don't want to include what were the warnings there. That's fine. Max floor 2, yeah, and I'll do na.r dot if, what did it say? If it's negative infinity. Can I do this? Does this work? It's still going to show the error, but if I say filtered, if I did a range max floor, yeah, it'll put the 0. Okay. I think that might have worked. All right. So the NAF. Okay. Then if so now I say this is by building, And we can map, I might also want longitude and latitude. I'm gonna do, let me see, are there ever multiple latitudes per building? So I'll do group by building ID, summarize latitude equals n distinct latitude. Nope, that'll be elevators. Arrange descending. Very, very, very rarely. Still, I'm going to play it safe and say latitude equals mean of latitude. Longitude equals mean of longitude. We're doing the centroid, just in case there are multiple in the same building, which could happen for, maybe, I would assume it's by building, but who knows. And yeah, now we're going to get the longitude and the latitude. Always nice, in case some have it and some don't. I think it's unlikely, but, All right, so now really we have this by building. I would say latitude, longitude, latitude, geom, point. Here we go. And I'm going to say, this is the fun bit. I'm going to say color equals max floor. And I'm also going to do, let's see, I want those gray dots. I just don't want those gray dots. For this graph, I'm going to say not isn't a max floor. That's not too impressive. I'm going to specify scale color log 10. Is it a U with the color? Does it not do that? Scale color continuous. Transformation is log 10. And I'm going to change the palette to be, there's a lot of ways we can do this. I kind of like low is, I don't know, low is blue, high is red, and midpoint is log 10 of, I don't know, 10. Let's show like, only show that the top ones is red. Let's make it 30, so only the, and now what I'm gonna do is use arrange a little more strategically. Arrange by max floor, because that's trouble. It'll draw them in order that I give it to give them. So it will say like the low, right now I want the lowest ones on the bottom, kind of makes sense, and then the highest ones on top. 30 is too much of a, yeah. Now we're kind of talking, like you can kind of see how we've got where the buildings are taller. We can kind of get an impression of it. And I'm gonna say theme map. Oh nope, GG themes. Theme map, because I don't want the I do not have that installed. One moment. GG themes is great. Emil, I gotta say, this is already like one of my favorites. It's really up there. This is really fun. All right, so now I can do GG themes. Okay, the longitude, latitude, yeah. But really I might want more like a choropleth, where, I can polish this up a little bit. I can say color equals height based on highest elevator and floors. Here we go. I can go with this, but the here we go. Absolutely quote me on that, Emil. What I would actually do is aggregate by zip code and borough, because I like to do borough too, and say summarize. We could do something like median. Well, we could do median height. We can do a lot of things on height, but what I'm gonna notice is, let's do yeah, I don't like any of these numbers are fractions or something else. So I'm going to say floor 2, let's see, if else floor is, or floor 2 less than 1. Floor 2, let's see. Oh yeah, that's fine. So let's look at this histogram again. So everyone, okay. There's this kind of like this distribution of a, that's interesting, there's a spike. That's probably because I think that's mostly the log shape, I think. It's kind of a mix of under 10, and then it drifts off with a long tail. For something like that, you could use the median. I would usually use the geometric mean, which is, let's set this up. So let's say n buildings is n, and we'll say mean, and the geometric mean can be done as the exponent of the mean of the log p. What's there? Log 1p, which is log plus 1. I'm going to make it more explicit. Max floor plus 1. And actually, we don't need a plus 1 because we know they're all very important is I do. So we log it, we average that, we exponentiate it. I'm going to call it geomean height. And now we see what are the tallest and shortest boroughs. This is a weird data. This is, I usually don't want to include one with too few buildings. So let's also say filter not is in a zip code for this analysis. And I'll also say, here we go, after this aggregation, I'll say filter, I'll do doc groups equals drop, filter, and you must have at least 10 buildings to ride, 10 elevated buildings with elevators in order to be counted here. Even that makes me uncomfortable. Like, yes, there are 12 buildings in 1020. Maybe those 12 are really tall. I live in 10023, so the Upper West Side. So and I'm not surprised I don't see that there. There's a lot of residential, but I don't know where 10020 is. I'm gonna say at least 20 buildings. I'm just gonna do that. All right, we're gonna say at least 20 buildings in the zip code, and we'll do by zip code. Could have done that in there are a few ways we could have done that, and let's also do tallest building, max floor, and yeah, let's do. So now we can take the zip codes and do a choropleth of them, do a map. So to do that, I'm gonna remind myself how we do. Let's see, NYC zip shape file. You know, I did zip code boundaries. You know what's fun is I like to do Command-Shift-Def and say zip code within, what have I used within here for NYC, actually to do trees by zip code, yes. This one I remember I did, I think I actually did that one live in front of an audience at one of Jared Lando's meetups. And here we go, wait, yeah, there's the tree. Now where's my shapefile read SF. Here we go. Zip code. Okay. So what I'll do is I'll do zip code boundaries. I just want to copy some code from somewhere else. Here we go. And yep, that put it into my downloads folder. So I can do geomsf. I'm gonna actually copy, because why not? I'm gonna copy and I'm gonna do, here we go. But instead of trees, it'll be joined. I'll join zip codes. Library SF, I need to, so SF stands for shapefile. And these shapefiles are contain like the boundaries of New York City zip codes. So I'm going to left join this in. And here we go. N. I'm gonna call it elevator building density. I'm keeping, this is not critical to what we're up to. I just want to, here we go. The object is an SF, and no, it's not zip code with an underscore. I called it zip code, or did I? Let's see. Oh, no, it's called zip code. There we go. Took a little bit of guessing, but I wanted to, yeah, we call it zip underscore code. So this is a shapefile, and what that means, I can do more interesting things with it. Then I can say I can actually use, what's that called? What did I call it? Geomean height and fill. I'm not gonna want maybe red, blue to red, and midpoint is. I'm gonna basically just mess with this. All right, nope. That is a boring plot. Oh, that's why. Log 10. Log 10 of, log base 10 of 10, which is actually just 0, but, or sorry, pardon me, is 1. I'm gonna make the log 3 story? Nope. Hey, what is the median? That's an interesting question. If I said by building, summarize median of max floor 6. I'm just using a 6. So we say the median elevator goes up to the 6th, at least in the data set, goes to the sixth floor. That's not crazy to me. One thing I think is you can only have a 5th floor. You can only have a 5th floor walk up. In New York, I don't think you can have a 6th floor residential building without an elevator. But of course, not all elevators have to go up to the 6th floor. You could have a 2 building. You certainly could have a 2 or 3 floor building. But it's not crazy to me. It's 6 is a natural point. See, and these NAs are ones that don't have enough buildings in them. I wonder if, yeah. I might not just want number of buildings. Might want n buildings with height. So, and that'll be sum not is in a max floor. And buildings height will be lower will be smaller than the number of buildings, sometimes by a little, sometimes by more. And I was noting that because I want to only include ones with where is my filter? There it was. There's my by zip code. N buildings height is greater than or equal to 20. I want to say only ones where we have at least 20 data points we're working off of. It's probably gonna be a very similar graph. So but I didn't want one with 20 buildings where only one of them had a height. Okay. So what do we see? We see Manhattan is, it's really Midtown Manhattan is tallest. Then there's, this is the downtown, like Greenwich Village and Soho and Tribeca is kind of this area where I used to live is Chelsea, which is, where is 1002? Where is 10001? Watch this. I'm going to say, I'm going to cheat. I'm going to say zip code equals, I used to live here in Chelsea when I was commuting out from Penn Station, and the, zip code, it's all caps. So I want to highlight that one. Nope. What's up here? Why? I was trying to just color that one. Here it is. And why? Where is that? Where is that one? Zip code. Fill equals. I kind of was thought this was gonna. Oh well. Oh, it's because I have scale fill gradient. Aha! That square one, that rectangular one. That's Chelsea. Thanks for indulging me. Okay, I think it's this one, yeah. So the point is that, yeah, then that'll be like the meat packing, stuff like that. The NoHo, I think, Yeah, East Village. And you see, then you get down to the financial district and it's more crowded again. And I'm actually going to zoom in for 1 second on this. I'm going to say filter borough is Manhattan. I don't like the legend placement, so I'm going to do theme legend position equals top. That's kind of nice. I like it on top. I'm actually going to keep that, and I'm also going to call it color is average geometric average height of buildings with elevators. All right. So the so then we can see kind of like, oh yeah, there's Midtown Manhattan, and then there's the financial district that are taller, and this is, what even is this? Well, anyway, yeah. So this is a pretty. I think this is a pretty cool set of Go. We're gonna keep this here. Why is my, oh, it's not a color, it's fill. All right, so that's a bunch of things on height from elevators. I can do other things with density, but the truth is, like, population density is more interesting to me than elevator density. We could do something on elevator density, but the but like, I don't know. I really like height. I really like this this kind of examination. Now I'm gonna look at it. I can look at it a few other ways. One is we could say by building. Let's see. We could have done it as. We could do max floor by borough. Geom box plot. Scale x log 10 and say, okay, here's distributions by borough. The distributions don't interest me as, oh, one I can see is that Staten Island kind of has a max height. That gives me an idea of what I'm gonna, that gives me an idea. I don't know my idea. I'm kind of thinking you could have one bar per elevator. That's too many. I don't like that idea anymore. I'm trying to decide on new ways to visualize, interesting ways to visualize this. I've got an interesting one, which is let's see if we can create the New York skyline. And what viewed from let's actually create this again. Here's a thought: is let's say a particular Manhattan viewed from New Jersey, which is over here. Let's say we do. So we're gonna actually keep. I'm gonna start with Manhattan viewed from dead on. It's not gonna be from a distance. So that means everything is like based on where you which is not quite right. But the idea is that if I did a plot, let's do filter. Borough is Manhattan. If I did a plot of latitude by max floor, I'd get a I could do a scatter plot. Already it's a little bit interesting, but let's change these from points to. We could do bar. Or really call. That is not gonna be. It doesn't care for that. Approach. I'm gonna use geom segment x end equals x end. Let's see. X end is latitude. Y end is latitude. X end Y is 0, Y end is max floor, and get a lot of lines. Here we go. Now we're seeing like New York viewed from Manhattan viewed horizontally. I can pick a size. If I say too big, it's going to be blocky. That's too blocky. That's too thin. Those don't look like buildings even from a distance. Those don't look like buildings either. I'm just eyeballing it because we don't have like the width of each building or anything like that. I don't know. That looks, it's maybe a little blocky, but I kind of still like it. So these are like, we can kind of see the tallest buildings, and let's actually say alpha equals 0.5. Alpha equals 0.2. I guess we can kind of see like, oh yeah, where's the block of there are a lot of buildings of this height. And yeah, now we can actually say like, all right, that's a good start. I wonder, do we have anything with neighborhoods in here? Just, wouldn't that be nice? I could say something like, let's see, do I have it in zip code? The zip code data joined. Nah, never mind. All right, then the so this is, I'm just gonna add in skyline viewed from the side. So this is this is showing like, I'm gonna call this one, I'm gonna say Y is floors. I'm gonna leave this one. And we'll say theme minimal. That's neat. I want to see something that, like, I didn't like some of my borough thing. The core thing is still cooler, but like you can really kind of see the bulk of the financial district in Midtown Manhattan, and then up where it gets past like I don't know, this might be the upper west side. And then once you get up to like Harlem and Riverdale and such, it's definitely shorter. Lots of buildings that are only a couple floors. Maybe this is something like 6 stories high. Yeah. So the what happened if I did? No, that's overkill. But if I'm not gonna keep it this way. I just gonna kind of see like, yeah, this is these clouds of buildings. But I'm gonna keep it like this. I think it's cool. All right. So the all right. So some more ideas from Angel. Let's look at plot by zip code and last per inspection date. So let's look at the let's look at. Go back to the original data. There's so much we didn't even look at because I've been so focused on height and geography. What time is it? Great, we have 20 more minutes. Let's see. That's status date, last per inspection date, and I can see it's we'll need a little bit of formatting, and approval date. What's last per? Let's check. Let's take a look at what we know about this data. Last periodic inspection, display last periodic inspection. I don't know what display means. NV, NF, okay. And there's approval date, inspection, it last was updated in 2015. That's why it stops there. So let's look at, first let's parse these. So we'll put in the clean code. What I'm gonna do is say mutate across from ends with date. I'm gonna add a function for parsing dates. So which I just need to quickly remember. It'll be parse. Well, how does this do? If I said parse date, it doesn't like that, but I can give it a format. I think. Let me see if I can get this on the first try. No promises. No. There it is. I don't know if that's the only way I could represent it, but %y, %m, %d, low cases, uppercases, the whole thing. Ah, yes, I always forget YMD. Wow. Thank you. Lubridate has YMD. Let's find out if YMD is smarter about... Oh, yep, well, only 32 failed to parse. Thank you. Select contains date. Keep forgetting YMD. All right. Then let's go down to the... so what could I look at? I'm going to start with... I'm actually more interested in approval date than I am in... the name inspection is because things get inspected multiple times, but like I just said, when did the elevator get approved? Now, we don't know if maybe the department was founded in this year or something like that, and then after that regulations changed, but it looks like most of them were the 90s, 2000s, 2010s, and last data point is in 2015. We could do like animations and stuff. I don't know that like, given that this is limited data, like if I really knew what date every building, every elevator was approved, I definitely would be excited about it. But I don't know. I will graph it. Let's go ahead and graph it. So let's say mutate decade. Let's do decade approved is year approval date 10 times. This will do is say actually I can do better than that. I can say floor date. Can I do this? Actually, I have no idea. Nope, doesn't like that. Wouldn't that be neat? I can just truncate it to the decade. Doesn't seem to enjoy that. So I'm gonna do this, and we'll say count decade approved. And we'll do borough. And I'll go ahead and say decade approved must be, we'll leave in 1970. I might get rid of that one too. Yeah. I don't see all that much interesting here. It's like, yeah, most of them are in Manhattan, then Brooklyn, then Queens, and Staten Island least of all. It's not telling me all so much. It stops in 2015, which is why it goes down here. So much so that I might say year. I might do it by year, by 5. And filter for don't include 2015. Even so, there could be reasons that this last one was lower. It could be that fewer buildings were being built, but it could also be the recent ones weren't added to the data set or something like that. Yeah, I don't think I'm getting too much right now for the date of the of approval. What do we see for date of inspection? Last periodic inspection date. Most of them recent. I'm also going to filter only for what is it? It's device status equals active. It doesn't like that. It's device status equals A. It's device status description. Yeah, it's like device status description is active. Sure. And now I'll add the so most of them were inspected in those last couple of years. Maybe sometimes it had been a couple of years. Yeah, I'm not gonna explore that I think too much, but yeah. All right. So, a question from Chris: could we make some kind of plot with a z-axis, like greater red color depending on height? Yeah. So we did, I think, do something like that where we said, let's see, we had this plot that was, where was it? This plot has a z-axis. Oh yeah. Let's do this. Okay. Let's look at 3D plot. So I've never actually done this before. But let's do ray shader R. Oh boy. Let's see this. All right. I've never done this before, but I've seen some really pretty ray shaders. Plots. Do we have a GitHub or a guide? Oh, here's a whole website. Here we go. Can I do this? Render points. I've never, yeah, like I said, I really have not used this. Plot 3D. What are like the simplest ones that I can do? I'm trying to see the, Ooh, that's neat. Actually, yeah. Can I do, I'm looking for the word choropleth. What do I got? I got 10 minutes, let's see. Nope. Oh. Because this is what I want. I want one of these. We say, let me see. Translate ratio ggplot 2. Yeah, I want to just plot gg filler color. Aha! There we go. All right, let's give this a shot. So this was one version, and now if I do library ray shader again, I'm very new to this. Oh no! This is the worst where I don't have OpenGL is not available in this build. Oh no. Wouldn't this be great if I could do let's see if I did start R. Can I do RGL? Nope. Okay. So that kind of answers my question. Let's restart R. Save this. Oh ho! All right, fingers crossed, fingers crossed. Let's do let's see what we got. Oh, I need to rerun all these things. I don't need to rerun all of these, but I will. Fingers crossed. Let's see what we got. All right, that's not showing up, is it? Magic, using basic shadow instead. All right. RGL widget. Okay. First argument should be an RGL scene. I don't know what that means. I don't know what that means. So if I did this, if I just called RGL widget, All right, so this, whoa! Look at this! How much better is this than the thing than whatever I was looking at before? This is it. All right, this is blowing my mind. This is blowing my mind. All right. Okay. Sorry. This I learned a lot of new skills here, but this is not this is just a kind of cool one. Okay. So this is 1 point for each elevator, for each building that has at least one elevator, and we can look then at the New York City skyline, like from the south or from the east, and we can kind of see this like on the red parts, or from, I think I like the you can really see this, you know, when I've been to Jersey a couple of times, you kind of or out on the water, you can see there's kind of this dip on that's like where Chelsea and such is, but the I love that the legend has its own dimension, which makes sense. But that was just so easy. Yeah, definitely took a little bit of a Stack Overflowing. Thank you, commenter from 2021. But the all right, that is, yeah. So these are some points, and now I'm gonna try one last thing, which is, can I get a map of New York City under this? So ray shader. Let's see. Map. Plot the current map. Let's see. Plotting my own map. All right. Oh, here we are. Overlaying. This is what I want. Or is it? Let me see. Get ArcGIS. Map image. I need a yeah, the box. Okay. Yeah. What I'm going to create is a bounding box, where I'm going to say the and bounding box is let's check what it expects. List. All right, I'm going to create it. So I'm going to say the min of by building longitude, min by building latitude, and change these to to max. So then I have the coordinates that specify oh, that's a local function. I can't that's not going to be a well, it's not, it doesn't seem to support it. So I do not know how to get a map from New York City. Like if I were to say I want yep, I can't do that. Yeah, I can't quite do this right now. Maybe I can copy that. Let me see. Here we go. Now the question is, do I need some kind of there we go. All right, let's see. It's let me see if I need some kind of some configuration. image, I don't know what my image size, width is, and height are going to be. Let's see. All right. I don't know, height and 60. Let's try. We'll try other things later. I don't know. But if this works, then nope. Well, maybe. No, maybe it does. Up. File is overlay file. Let's see. Output file. It's giving me a URL, but it doesn't seem to be downloaded. Oh, well, there you go. That is not. Oh no, that. Nope, is not right. That is too much. Those are not the coordinates I was expecting. What's doing down here? I do not know. The max. Oh. Long lat. Oh boy. Yep. Closer, but did I get this right? Lat. Oh, wait. Min, max. Yeah, I think long. Yeah, I think I did get this right, but for whatever reason, it's not quite so weird dimension. Maybe just because of the dimensions I gave are strange. In this range. I did, what is the range of this? Just min, max. Longitude by latitude. So it's wider than it is tall. So the, because longitude is width. So if I did, I'm kind of eyeballing it here. I don't know why the download's not working, but it is all right. Yeah, but even if I even if I downloaded this, it would take some more work to get this set up. I'm not gonna mess with that right now. I just this is a really good. I'm not always a fan of 3D plots, but there's no question that when we're doing like geography and height, this is the viz we were looking for. Yeah. So, that was really fun. I don't think I'm gonna top that. I will note there's a lot else in Elevator. We use a lot of geography. There's things like what's the speed in feet per minute. Oop, nope. Select speed. I'll use Parse. So we can say things like, what are the fastest elevators in New York City? We can do that. We could have done that by location. Distribution where it looks like typical is about typical is around 100, which I don't know if it's real, but then we have these this kind of distribution. I assume that the taller ones are something I'd be curious about is are the taller ones faster? I would hope so, or really the ones that are, let's see, geom point scale x log 10 and y log 10, and there are some really fast ones that are too. Oh, but let me also do mutate floor from equals. Well, actually, yeah, I've got a there is one that is in distance, which is travel distance. Elevators travel distance. Ooh, it just hit me. It hit me. I should not use a sorry. We have things I can do like let's see, travel distance. And lots of units. Let's not spend too long on that. One thing to for floor from is as floor from And let's do floor 2 minus floor from. Number of floors it covers. So there's a lot of weird stuff around the ones that are supposedly one floor. And then there's like the taller it is, or only one apart, or somehow the same floor. And then generally, yeah, as you get taller, you need it tends to go fast. You get those kind of express elevators. All right, but yeah, I wasn't gonna try and parse this. Yeah, this would have been very messy to parse. One thing that occurred to me is back when I did this ray shader, I should not use a log scale because the distances here are meaningful. They're the let's see. Just noting this. I would call it half-hard. I'll say it is an attempt. So I don't want that log scale. Here we go, here we go, here we go. And then we do, let's see, what was it called? Our, here it is. And now I don't want log 10, I want just 10. This is going to be actually a more evocative plot. No, yeah, this is actually less good than I was originally hoping. No, let me see. Midpoint is 3, 6. Give it a second. You know, it's funny. I don't see, where is my blue? There's little blue around. This. Yeah, I was hoping for something a little more evocative than this. Oh, also there's some kind of rendering issue over there, but the yeah, I really I don't quite understand why so many ended up scale, color gradient, blue to red, midpoint 6. I don't know. The point is, what do we do today? We got this elevator data. We saw this was an unusually data that needed an unusual amount of cleaning for Tidy Tuesday, which I really like because I do find cleaning data rather fun. And then we looked a little bit at some things like status and borough, but really I want to jump straight to two things, which are heights and locations of buildings. We looked at a distribution of height, kind of where I got something like they might want 6 to be maybe the median. We aggregated by building because there can be multiple elevators in a single building. We looked at some of the top ones and looked them up, but then really the key was all about looking at these these visualizations. Oh, there's my see the max floor by building. So see, I don't understand where all the blue points. Oh, they're on the bottom. That's why. That's probably why why we don't see low points, because it just was that's because of the ordering, which is reasonable. But the actual really interesting thing was the and yeah, that's a good point. If I did a midpoint of 12, what happens? I can't stop making ray traces. Now, yeah, we tried doing some things with getting the map. We ended up and I ended up giving up. But but yeah, what else do we see? We going over today because I'm having so much fun. Yeah, still can't quite see the blues get kind of crowded out by the white points that are plotted right on top of the bit. Still great because we're still seeing this kind of yeah, we're still seeing these spikes, and yeah, I think it really is it's a cool data. It's oh, yeah, we also did one other thing, which is, yes, I forgot. We spent so much time on those fun plots. Forgot that we did also join in a shape file. Anytime I see zip codes, I think I'm gonna try out a core plot by zip file, and this communicates some a bit of a wider range in terms of, yeah, here's all of Manhattan, where are the here's probably not all of New York City, Queens and Brooklyn, and oh, that was another thing, is I think I did this plot. Can't stop me. This plot was by, I can't remember. Did it include? Yeah, no, it included everything, which is good. So yeah, so we have we also had our choropleth and our first attempt at viewing something from the side before we did the ray tracer, which I'm gonna bring, so I can do this in the right order. I'm gonna bring this down here. One more. Oh, that's I got a good suggestion here. I see I can't not gonna stop. It's so much fun. Let's see one moment. Bring this to the bottom. I'm gonna move the code, and yeah. So the question is, I've got this choropleth where we look at the here we go. What if I did? What if I now did plot ggg RGL widget? The question is, what if I plotted this? It's a question from Chris. Did I mix something up? Join zip codes. That does not look. Oh, it's because I didn't clear it. How do I clear? Ray shader, clear, RGL. Try that. That's why it wasn't working earlier. I didn't clear it. PlotGG didn't that's why it started looking weird and all covered up. Here we go. Okay. I think what's happening there is that I have too much data. Let's see. That's like too long a title, and that's why it was crowding out the actual legend. Here we go. Yeah, look at that. There we go. We kind of see. I bet we could control what it looks like from the side, but mostly, yeah. There's our ray trace. There's our ray trace. Average floors. Call it average floors for next time. Yeah, look at. Trying to get a good screenshot for Twitter. Really cool. Yeah, now that I know I did, yep, we got all these little zip codes in here. Yeah, we can kind of like see. So that is that's cool stuff. And but yeah, the other thing I'm gonna do is, now that I know about that, I'm gonna go to the other one that I did and say, here we go. Plot it by building. Learning new skills always takes some. Oh, nope, it still looks. Now at least I do see the blue. But yeah. All right. All right, that was lots. All right, so we did waitress, we did SF, we did lots of fun things. If you enjoyed yourself today, please do like and subscribe the video. I definitely look forward to seeing you again. And you can find all this on my GitHub. So yep. I hope you had fun. I certainly did. I will see you next week.